Mathematics 1 DM015 by Mathematics Unit KMNS. Chapter 4 Functions. There are 4 subtopics, and now we will discuss 4.2 types of functions. At the end of this topic, students should be able to sketch the graph of linear, quadratic, cubic, and set functions. Determine the domain and range of linear, quadratic, cubic, and set functions. The graph of a function. The following are 4 graphs of functions that will be discussed. First, linear function. Second, quadratic function. Third, cubic function. And fourth, set functions. Domain and range of a function. Domain of fx is the set of values of x for which fx is defined. Range of fx is the set of values taken by fx. We can determine the domain and range using graph and algebraic approach. The graph of a function and domain and range. First, constant function. Let's say fx equals k, where k is a constant. From the graph, fx equals k is a horizontal line at value y k. The domain is real numbers and the range is k. By using algebraic approach, from fx equals k, fx is defined for all values of x. Therefore, the domain is R, real numbers. Fx only takes the value k. Therefore, the range is k. Now we will enter linear function in the form of fx equals ax plus b. From the graphical approach, when a greater than 0, which is positive, the graph is like this. And when a is less than 0, the linear function graph looks like this. From the graph, we can see that the value of x starting from negative infinite to positive infinite. Therefore, the domain is real numbers. And the range is also real numbers. By using algebraic approach, fx is defined for all values of x. Therefore, the domain is real numbers. When we change x as the subject of the equation, we can see that x is defined for all values of fx. The range is real numbers. The third function, quadratic function, fx equals ax squared plus bx plus c. From the graph, we can see that the minimum point occurs at y equals k. The domain is real numbers and the range is k to positive infinite. For the graph with value of a less than 0, it has a maximum point and it occurs at value of y equals k. The domain is real numbers and the range is from negative infinite to k. For quadratic function, by using algebraic approach, we can see that all values of x is the domain because fx is defined for all values of x. We need to transform the function by completing the square to the form fx equals a in bracket x minus h square plus k. If a greater than 0, fx has a minimum value of k. The range is from k to positive infinite. If a less than 0, fx has a maximum value k. The range is negative infinite to k. Cubic function. Fx equals ax cubed plus bx squared plus cx plus d. By using graphical approach, for a greater than 0 and a less than 0, we can see that the domain is R and the range is R. By using algebraic approach, fx is defined for all values of x. Therefore, the domain is real numbers. Fx also takes all values of real numbers. Therefore, the range. Sketching the graph of a function. First, linear function. Second, quadratic function. Third, cubic function. And fourth, third function. For a linear function, tips on sketching the graph. First, find 2 points on the graph. Substitute any value of x into the function. Use the intersection point on x and y axis. Connect that 2 points by a straight line. There are 2 points on the graph, which we use the intersection point on the x and y axis. And then, now we connect the 2 points by a straight line. So that's how we sketch a linear function. For quadratic function, tips on sketching the graph. Find the minimum or maximum point by using completing the square. Then, find x-intercept and y-intercept if exists, which intersection with y-axis happen at x equals 0 and intersection with x-axis happen when y equals 0. Next, draw the graph. For example, for a greater than 0, which it is a smile graph. It has the minimum point and it happened at HK. When A less than 0 and the graph has a set graph, it has a maximum point like this. It happened at HK. For cubic function, tips on sketching the graph: find x-intercept and y-intercept, which when x equals 0 and y equals 0. Then draw the graph like this. We have one intercept with y-axis and two intercept with x-axis, and A is greater than 0. Therefore, the graph is like this. For the second graph, we have intercept with y-axis, two intercept of x-axis, and A less than 0. Therefore, the graph is like this. For third function, tips on sketching the graph: find the domain first. Whatever function in the third, it must greater than or equals 0. Then find x-intercept and y-intercept if exists. Last, draw the curve. For example, find the domain and a point. Which is real numbers. The range is negative infinite to positive infinite. B. Fx equals x squared minus 6x plus 8. Points on the graph: when x 0, fx equals 8. When y 0, x squared minus 6x plus 8 equals 0. Factorize this quadratic equation, we get x minus 4 times x minus 2, which the intersection with x-axis occurs at x2 and 4. When we sketch the graph, we can see that the domain is real numbers. By completing the square, f has a minimum point at 3, -1. Therefore, the range is from -1 to positive infinite. Fx equals negative x squared plus 12x minus 35. Points on the graph: when x 0, fx is negative 35. When y 0, x squared minus 12x plus 35 equals 0. Therefore, x equals 5 and 7. When we plot the points on the graph, we get a set graph because a is less than 0, which is negative. The domain is real numbers. By completing the square, f has a maximum point at 6, 1. Therefore, the range is negative infinite to 1. Hx equals square root x minus 4. Points on the graph: we will take square root x minus 4 equals 0, which is y equals 0, happen at x equals 4. And when we find h8, we will get equals 2. Now we find the domain. As square root of x minus 4, we just take x minus 4 more than equals 0. Therefore, we get x more than equals 4. That is the starting point on the graph. Happen when x4 and y0. And the second point that we calculate just now, when x equals 8, you will get y equals 2. Now we connect these two graphs, 2 points, as the graph of third function. From the graph, the domain is 4 to positive infinite, and the range is from 0 to positive infinite. Hx equals square root x plus 3. Points on the graph when x0, h0 is 3. Find another point on the graph when x4, h4 equals 5. Now we plot these two graphs, these 2 points on the graph. It is 0, 3 and 4, 5. By using the pattern of third function, we get this is the graph. The domain from the graph is 0 to positive infinite, and the range is from 3 to positive infinite. Example 2. Use algebraic approach to find the domains and range of the following functions. Fx equals x squared minus 6x plus 8. Fx is defined for all values of x. Therefore, the domain is real numbers. Fx equals x minus 3 square minus 9 plus 8 by completing the square. Therefore, the range is from -1 to positive infinite. For the function hx equals square root 4 minus x, we get the domain is -infinite to 4. By taking 4 minus x more than equals 0, we get x less than or equals 4. And the range is from the starting point, it is 0 to positive infinite. End of 4.2.